All right, so we're going to talk about direct and joint variation. We're going to go over what the difference between the two types are, how to set them up, and then how to solve them. So we're going to start with direct variation first. So this is when the quantities that you're comparing are directly related. So as like whatever one quantity does, the other quantity does the exact same thing. So if one increases, the other increases. If one decreases, the other one decreases. Those kind of things. So a couple of vocabulary words. Independent variable is when you're talking about like a set of data. And a lot of times when we talk about data, we have like an X and a Y. The X is usually your independent variable. That means that it's unaffected by the other data. So a lot of times, like time. So like the number of days in a week is consistent no matter where you are. We have the same number of hours in every day. There's the same number of days in every year and all of that stuff. That's going to stay consistent no matter if you're here or if you're in another country or if you're 50 years from now or 50 years ago, everything stays the same. Dependent variable would be dependent upon the independent variable. So it's influenced by what's happening. So the example they give is that an independent variable would be the number of apples purchased. Like you can go and decide, do I want to buy 5? Do I want to buy 10? Do I want to buy 1? What you can't control though is how much an apple's going to cost. Okay? That's determined by somebody else. So depending on how much, each one costs, that could then influence how many you buy. But those two things would then be related that way. So we're going to start by talking about direct variations. So to set up a direct variation, figure out what your two pairs of data are and figure out how they're related to each other. Write one pair of the data in the numerators of your two ratios. So we're still going to be like setting up proportions like we saw last week and cross multiplying and solving them that way. So your data, you want to put them like both in the top of your fractions and then write the other pair of data in the denominators. So this could be, for example, like, okay, I bought this many apples for this price at this store, and then I went to another store and I saw that they were this price and I want to know how many apples I could buy for the same amount or something like that. Form a proportion, use those two ratios, cross, multiply, and solve. Okay, so let's do some examples here. Number 1 says find the cost of 10 apples if 4 apples cost $1. So what I'm going to do to set this up is put like the number of apples over the cost. Okay, so I bought 4 for $1. So I bought 4 apples for $1. I want to figure out how much it's going to cost for 10 apples. So where should the 10 go? On the top, because that's the number that I want to buy. And I'm trying to figure out how much it's going to cost. So you can put a letter to represent the unknown. So then we cross multiply like we did in the last section. So big X, or use your butterfly method and circle your numbers up. So you're going to have 4x, 4 times x, equals 1 times 10, or 10. And then we're going to divide by 4. So 2.5. So this is going to cost me $2.50 to buy 10 of them. So 4 of them cost me $1. 10 of them are going to cost me $2.50. So the second one says, how many apples could be purchased for $10? So I'm going to use the same setup here. So I'm still going to put the number of apples over the cost. And I'm using some of the information from up above, which said that I bought 4 of them for $1. This time I want to know how many could be bought for $10. So where does the 10 go for this problem? In the bottom, because that's the cost. That's how much money I want to spend. And I'm trying to figure out how many apples I can buy. So then we cross multiply again. Now this time, 1 times x is just going to be x. 4 times 10 is going to be 40. So this means that I should be able to buy 40 apples. All right, let's take a look at the next one. So a truck travels 102 miles on 6 gallons of gasoline. How far will it travel on 30 gallons of gasoline? The way you set up your proportion doesn't really matter. You just have to keep it consistent. So you could put miles over gallons, or you could even put gallons over miles. That's not going to make a difference. Usually if we think about what it would be, we usually talk about like miles per gallon, MPG. So I'm going to put miles on top and gallons on the bottom. So I did 102 miles for 6 gallons. They're asking how far will it travel. So that would be asking how many miles something can go. So that's where my variable is going to go on the top. 30 gallons is going to go on the bottom with the 6 gallons. Okay, and then we cross multiply just like we did before. So 6 times x is going to be 6x. 102 times 30. Good, 3,060. And then I divide by 6 to get x alone. So what is it? 510. So that means that they should be able to travel 510 miles. Now when you do these problems, it's assuming that everything's going to stay consistent like forever. So this is not taking in, like in this case for this person driving, it's not taking in consideration if like they are maybe like if it's a truck driver in the mountain area and they're going up and then that reduces their gas mileage. They're like assuming for these kind of problems that this person's driving flat consistently, which is unrealistic for the most part. But this is just kind of an estimate that you could use to figure out like what could they expect it to be. So if I actually did this like in real life, it could be a different number, but again, I'm not taking in all those other factors that could affect this. All right, so for this next one, it says if a metal rod tapers 1 inch for every 24 inches of length, what is the amount of taper of a 30-inch piece of rod? So how I would set this up is like the amount that it tapers over the length. Okay, so I'm going to give you guys a minute, 30 seconds to a minute. Set this one up and try to solve it. So for setup, 1 inch of taper for every 24 inches. So I would put 1 over 24. And we're trying to figure out the amount of taper. So that's going to be your variable, and that's going to go on top for a 30-inch piece. So 30 goes on the bottom there. Cross multiply here, you're going to have 24x equals 30. Then you're going to divide by 24. Anybody able to tell me what you get? Good. 1.25, or 1 1/4, and that would be inches. So we're going to move on now to some problems that are still doing a direct variation, but this time we're using what's called the constant of variation. Constant of variation is a fancy way of talking about the slope. Okay, so in Algebra 1, when I talk about this with my students, when we talk about constant of variation, we're talking about slope of like a line. How much is it rising? How much is it, running over time? What's the slope? So we're going to kind of talk about that a little bit here, but we are going to be using a ratio to talk about this. Now, this right here, where it says k equals y over x, what I'm highlighting in blue there, that's your formula for the constant of variation. Notice it's really similar to your slope equation. Okay, if you don't remember slope from algebra, that's the change in your y over the change in your x. So you guys would have done like your y minus y over x minus x if you were looking at a pair of coordinates. It's the same thing here. It's y over the x. They use k to represent the constant of variation. So that's that number that is kind of acting as the slope. They just don't use m for slope. They use k. K is normally used in any problem that talks about a constant. And the constant would be something that is always staying the same. And it could be used for multiple problems to like do some predicting. So in order to find the constant, figure out your pair of data, how they're related to each other. Write the data pair as a ratio. Okay, so very similar to what we were just doing. And then either leave your constant as the fraction, or if you want, you can write it as a decimal. So like if it was 4 over 5, you could leave it as 4 over 5, or you could give me the decimal for that if you wanted to. All right, so this is used a lot when we're talking about like the cost of something and we want to know how much one item costs, or like if you're going grocery shopping and you're trying to figure out what's the better buy. Okay, so there's times when you go and you can buy the same product, but it's packaged 2 different ways, and you have to be able to know which is the better buy for your money. And that's when we talk about unit price, like how much something costs per unit. And that could be like per ounce or per pound or something like that. So we've got that a 15-ounce box of cereal costs $2.29. We want to find the constant of direct variation to the nearest 10,000th of a dollar for the cost per ounce. So I want to know for this 15-ounce box of cereal, how much is it costing me per ounce of cereal here? So I'm going to use that formula k equals y over x. Using the information that they give me, remember that y is your dependent variable, x is your independent variable. So the independent variable in this case would be I cannot control what the company is going to, like how much they're going to put in a box. Okay, that's up for them to decide. Do they want to make their boxes have 15 ounces or 20 ounces or whatever? So in this case, it's 15 ounces. So that's going to go on the bottom. The cost is $2.29, so that's going to go on the top. So I'm taking the cost divided by 15 to figure out how much it costs per ounce. So we're going to get a decimal here, and they say the nearest 10,000th. So when I divide this, I get a really long decimal. I get 0.15266666666. Mine eventually says 7 because my calculator rounds it for me. Okay, but it's 6 repeating. So 10,000th means you go out 4 decimal places. So you go out 4 numbers after the decimal. So it'd be 152. Now since it's 6 repeating, I'm going to round up to 7. Okay, now this would be cost per ounce. So it's a little over 15 cents an ounce for this box of cereal. So then they go on, number 2 here, and it says, so a 15-ounce box of cereal costs $2.29, or the same kind of cereal coming in a 36-ounce box costs $4.89. Which one is the better buy? Now up above, you already did the first one. Okay? This is the same thing as this. So we already know what the unit price is for the 15-ounce box. So I want you guys to use the information now for the 36-ounce box of cereal, which I have highlighted in orange. Find the unit price for that, and tell me which one you think is the better buy, the 36-ounce box or the 15-ounce box. Okay, so we're going to take the cost, $4.89. We're dividing by 36 ounces. Can anyone tell me what they got? 13. Okay, I think there's an 8 if you keep going. That's all right. Okay, so that's the price per ounce for a 36 ounce box. Which one's cheaper? Yeah, the 36 ounce box is going to be cheaper because it's costing me a little over 13 cents per ounce, where the other one is costing me 15 cents per ounce. Okay, so we would then say that the 36 ounce box is a better buy because it costs less. The next time you guys go to like a grocery store, or like if you go to Walmart, take a look if you're in the grocery area. Most of the time, they actually have the unit price already on the items for you, so you don't have to like do this in the store for most items. Now that would be like most prepackaged items. They're not going to do it necessarily for like your fruit or anything like produce that you have to pick yourself. But next time, like, just walk down an aisle and look. I think at Walmart, it's right on the price tag. There's like a little orange box or something. That'll actually have the unit price for you. And like I said, it's useful if you're trying to buy things and you're trying to figure out what's going to be the better buy, so that you're not wasting a whole bunch of money buying smaller items when you could save a little bit by going a little bit bigger. Okay, so moving on, it says next, like, to solve problems of direct variation using the constant. So instead of just finding the constant of variation, now what we're going to do is, if you either have the constant or if you have found it already, being able to use it to solve problems. So you're still going to see this formula show up, and that would be if you had to find the constant. Once you have the constant, all of our equations look like this: y equals kx. These are for direct variation, where y and x do the same thing. They both increase or they both decrease. And k, remember, is your constant, or it's a fancy way of talking about slope. Okay? So what we're going to do is look at a couple examples here, and actually either, like, we'll start by finding the constant of variation and then using it to solve problems. So this is saying that an architect's drawing is scaled so that 0.25 of an inch represents 5 feet. That means on the drawing, a quarter of an inch represents 5 feet in real life. Find the actual measurements for the following measures shown on the drawing. Now, we could use proportions to set these up too. That's an option. But if they want me to use this constant of variation method, I'm going to first find my constant. So I'm going to do k equals y over x. And so usually, like, the actual distance in real life is going to be your y. So I'm going to put 5 on top, and the drawing, the 0.25, is going to be on the bottom. Which, if I take 5 and I divide by 0.25, that comes out to actually be 20. And so that would be feet per inch. So what that means is, like, on the drawing, if I had a full inch, that would represent 20 feet in real life. So part A then, now actually going into some of the solving here. Part A, we're going to use the equation y equals kx. I want to figure out how many feet it's going to be if the drawing has 0.75 of an inch. So I'm going to take that 20, that's my constant, times the 0.75. So if I do that, I get 15. Okay, you guys do B. What is the actual length going to be if it's 1.25 inches? All right, what'd you guys get here? Good, 25. So 1 1/4 inch on my drawing would be 25 feet in real life if I went there. Okay, and that's used a lot in architecture. You know, if you're going to build something like a house or a property of some sort or like a building, you're not just going to show up to the property and just start building. You're going to have plans that you're using so that you know how long things should be, how wide things should be, how much material you need, and all that stuff. All right, let's go to the next page. So this goes into talking about a joint variation, which is a little bit different than a direct. So a joint variation is when one quantity varies directly as the product of two or more quantities. You guys know what the word product means? Multiplication. So this would be if I have to take a couple of items and I multiply them, and that relates to another quantity. This would be what's considered a joint variation. A lot of times, like what that would look like as a general equation would say y equals kxz. Like you'd have another variable added on after the x. You can still find like the constant the same way. And you maybe don't have to, like they might give you a problem that already has the constant. Like if we look at this first example here, it wants us to find w if w varies jointly as x and y. So they've changed the letters a little bit. So instead of doing y equals kxz, it would be w equals kxy. Okay, where k is still the constant. So it says x is 140, y is 6, and the constant of joint variation, that's your k, is 0.5. So I'm going to take 0.5 in for k, 140 in for x, 6 in for y. So I want you guys to multiply that, and somebody tell me what you get. Okay, so that would be what w equals. Another instance that you see this happening, and we've talked about this equation in a previous chapter, is for an interest, like a simple interest problem. Anyone remember what that equation is? I equals PRT. I had a student last year who would always say, I equals party, PRT. That's how they remembered it, okay? So interest, simple interest would be the amount of principal, that would be the amount that you put into the account, times its rate, so that would be a percentage, and then time, which is done in like a year, like a yearly basis. So 1 year, 2 years, 3 years, and so on. This is saying that the simple interest for an account is jointly proportional to the time and the principal. If the quarterly interest for an account balance of $7,000 is $87.50, find the interest on a balance of $8,500 for 9 months. So we're going to have to do a couple of things for this problem. First of all, we have to figure out like what the interest rate is. How much are they earning back for this money sitting in this account? So they first say that the balance, an account balance of $7,000, earns $87.50. So that's the amount of interest that they earned. So I'm going to put that in for I. Now P is the 7,000. I don't know what R is. And they say quarterly interest. Okay, so they're taking a year and they're dividing it into a quarter. So every quarter is when this interest gets compounded and they add the money to the account. So a quarter would be 0.25. Okay, and then we take it times R. Now to solve, I'm going to take 87.5 and I'm going to divide by the 7,000 and divide by the 0.25 to get R of 0.05. Now, that would actually be 5%, but I'm not going to write it as a percentage because I'm going to have to use it in my next problem here. Because that was for the first piece. They want me to figure out what's the interest on a balance of $8,500 for 9 months. So this is like a second half of the problem. I don't know what the interest is. This time the principal is $8,500. The rate is 0.05. Okay? If you think about 9 months out of a year, how many months are in a year? 12. So what would be 9 over 12 reduced? 3/4, which would be 0.75. So that's how much of a year we would have. We don't have a full year for this problem. 9 months would be 3/4 of a year. Okay, so can you guys multiply and tell me how much they would make in interest there? Good. $318.75.